Hey friends, welcome back to another video. We are going to discuss about the Kubernetes architecture today. Let's get started. Kubernetes follows a distributed architecture with the multiple components working together to manage the containerized applications. The system is primarily divided into two components, master node and the worker node. So what is master node? Master node is essentially the brain of Kubernetes cluster, overseeing its operations, maintaining the desired state and ensuring the coordination of tasks across all nodes. It also serves as a control plane for managing and interacting with the cluster, while the worker node executes the task assigned by the master node. What are the components of master node? First one is the API server. The API server is the entry point for all administrative and user operations. It exposes the API which client uses to interact with the cluster. These components process the RESTful API requests, validate them, and update the cluster state. So, what are the features or what are the things which API server is taking care of? Authentication and authorization. The Kubernetes API server authenticates the request and determine whether the authenticated user has the necessary permission to perform the requested action. For an example, when executing the kubectl create deployment command, the kubectl utility extract the authentication and authorization details from kube-config file. Subsequently, these details are sent to the API server along with the create deployment command. The API server then validates the provided credentials and determine whether to execute the command based on the authentication status. Next is validation. It validates the request to ensure they confirm the specifications defined in the Kubernetes API. This includes checking the proper object format, required field, and other constraints. HCD interaction. It's another important thing. The Kube API server communicates with the HCD data store to store and retrieve the cluster state information. HCD is a distributed key value store used as a primary data store for Kubernetes. And API server is the only component that interact with the HCD server. Admission control. So it enforces the admission control plugins which are responsible for making decisions about where to accept or reject the request based on the custom policies. This can include validating the resource configurations or mutating the requests before they are persisted, etc. So, second component which we need to talk about is a controller manager. The kube controller manager runs controller processes that regulate the state of the cluster. These controllers handle the tasks such as node management, replication control, which ensure the desired number of pods are running, endpoints, which populate the information about the running services, and many more. The another component which we need to talk about is the scheduler. The kube scheduler is responsible for assigning the workload, that is pod, to the worker node based on the resource availability, quality of services, and other constraints. It makes a decision on where to place the pod in the cluster to optimize the performance and the resource utilization. For instance, when the kubectl create deployment command is executed through kubectl utility, the API server first update this request in the HCD server. Then forward this request to the scheduler queue. The scheduler, upon receiving the request, seek the detail on existing worker node, including availability, capacity, and other metadata from the API server. The API server get the latest details from HCD and send this detail back to the scheduler. The scheduler, through a multi-processes, identifies the optimal worker node for the pod and communicate this information back to the API server. The API server subsequently updates these details in the HCD and notifies a kubelet, which we'll talk about. It's a component in the worker node of specific node regarding the request. The kubelet, in collaboration with the kube-proxy and the container runtime process to create the pod and update the status back to the API server. The API server in turn update these details in the HCD and responds back to the customer. So what next is HCD. So HCD is a distributed, highly available key value store used to store the configuration data of the entire cluster. It serves as a persistent storage for all cluster data, including information about the nodes, pods, services, and configuration settings, and many more. We can take the backup of HCD data to restore the cluster in case of any down issues. So these are the main components which is in the master node. Let's talk about the worker node. A Kubernetes worker node is responsible for running containers and executing tasks assigned by the master node. The main component of worker node include kubelet, Ku- kube-proxy, and container runtime. So, what is kubelet? Kubelet is an agent that runs on each worker node and is responsible for ensuring that the containers are running in a pod. It communicates with the master node's kube API server to receive instructions and report the status of the container. So, what is the responsibility of kube-proxy? Kube-proxy is a network proxy that maintains network rules on the nodes. It enables communication to and from the pod with the cluster and perform a load balancing for the services. Kube-proxy ensure that network connections are properly established. So next one is a container runtime. So container runtime is a is a software. It is responsible for running the containers. Kubelet support various container runtimes such as Docker, Containerd, and many more. The container runtime pulls the container images and launches the containers and images in their life cycle. These components works together to execute and manage the container on the worker node. The kubelet take care of containers runtime aspect, kube-proxy handle the network communication and container runtime execute and manage the container themselves. So what are the different components within the worker node? So there is pod and containers. Pods are basic building block of deploying the applications in Kubernetes. Pods are abstractions or simplifies the deployment and management of multiple containers within the Kubernetes environment. Each pod in Kubernetes is assigned with its own unique IP address. This IP address is used for communication between the pods within the cluster. The IP address is associated with the pod and remains as same as long as the pod is running. Next important thing is the service. In Kubernetes, the service is an abstraction that defines the logical set of pods and policies by which to access them. The service enables network communication between different parts of the applications and provide a stable endpoint that can be used to access the application, even as pods are created, terminated, or scaled. Instead of directly accessing the individual pod, application can interact with the service, which act as a stable and discoverable endpoint. They provide a crucial layer of decoupling, allowing the application to dynamically scale while maintaining a consistency and reliable way for other components to discover and communicate with them. Apart from this one, there is a pod network which is also playing a crucial role in the Kubernetes architecture. It's often referred to as pod network and is a network abstraction that allow communication between pod within the cluster. The pods are the smallest deployment unit, as you know, and the popular network in Kubernetes cluster include Calico, Funnel, Views, etc. This plugin handles the complexity of networking in a distributed environment, allowing for efficient and secured communication between the pods within the Kubernetes cluster. I hope you understand the Kubernetes cluster architecture. Thanks for watching.